Courses in the cement industry. Present to you. In this course will be explained. Rotary kiln drives. Part 2. Covered in this section. Mesh, reducer condition, contact, radial runout, and axial runout. Inspection of gear drives. 1. Add life to your gears, through regular inspection. 2. Establish a checklist for systematic inspections daily, weekly, monthly, and annually. The following items are critical elements of good gear maintenance. 1. Mesh. 2. Reducer condition. 3. Contact. 4. Radial runout. 5. Axial runout. 6. Tooth profile. 7. Temperature. 8. Lubrication. See this video. We follow together. Regular visual inspection. 1. Mesh. Proper backlash and root clearance are critical to smooth gear operation. Too much or too little clearance can cause problems that contribute to accelerated wear and loss of tooth profile. Also important is the longitudinal relationship of the gear relative to the pinion. 2. Reducer condition. Inspect for vibration and elevated temperatures of the reducer. These are usually signs of worn bearings or gears, or a lubricant problem. 3. Contact. The contact pattern across the tooth face is a telltale sign of gear alignment. If an axial runout condition exists, the contact pattern will vary with the rotation of the rotary kiln. Angular misalignment between the gear and pinion results in partial tooth contact, concentrated loads, and premature gear wear or failure. Gear contact pattern. In this picture it is explained. In principle, 4 components for a long life. See in this picture. Gear contact pattern. We follow together. Gear contact pattern. In this pictures it is explained. Contact patterns due to assembly faults, or operational conditions. From the previous show. Contact patterns due to assembly faults, or operational conditions. A. Pinion is running out, wobbling. Check fixation of pinion and shaft. B. Ring gear is wobbling. Assembling and adjustment of ring gear must be checked. C. Edge pressure. Pinion must be realigned axially, or slope corrected. D. Pressure spot on total circumference ring gear. Manufacturing fault or new pinion wearing into existing wear pattern of ring gear. E. Pinion diameter enlarged on both sides, due to wrong assembling, or ring clamping devices. F. Ring gear joints and fixation of both ring gear sections must be checked. G. Radial runout of ring gear. The picture of contact is stronger over 1/2 of the circumference. Radial readjustment is necessary. H. The ring gear has opened on both sides, due to thermal expansion. I. Ideal pattern. In this pictures it is explained. Girth gear radial runout. 1. The shell temperature of the machine must be uniform, while runout measurements are being made. 2. The proximity of other heat-producing elements may have to be considered. On this slide, We'll explain. Girth gear radial runout. 1. Occurs when the axis of rotation of the gear changes as the rotary kiln rotates. 2. Some slight change can be expected, but if measurements are taken and show a large variance, corrective action should be initiated. If the gear is accessible through the inspection port, a dial indicator should be placed on a 2-inch by 2-inch angle iron tripod at the appropriate position. If this is not possible, part of the enclosure will need to be removed to provide access. 3. Measurement of radial runout is done by dial indicator. 12 teeth, equally spaced and numbered around the circumference, that is every 38 degree, should have their top faces cleaned. The gear is slowly rotated, while the gear is moving the indicator stem is held back. The gear is stopped at each of the 12 teeth, and an indicator reading is recorded. 4. A rigid setup is required for the dial indicator, and extreme caution should be taken so as not to disturb the indicator placement during the procedure. 5. Take the maximum reading and subtract the minimum reading. This is the radial runout. Compare this to the acceptable value for your gear. Values exceeding the acceptable values will reduce the service life of the gear set. We follow together. Girth gear radial runout. In this picture, recommended runout 0.0015 inch. Foot pitch diameter. From the previous show. 1. Illustrated in the chart are typical curves for the allowable radial runout of girth gears for rotary kilns and similar roller-supported equipment. The allowable radial runout is, as with axial runout allowances, a function of the gear diameter. 2. Gear manufacturers and OEMs of rotary equipment typically recommend 0.0015 of radial runout per foot of pitch diameter. This applies to new installations, and to gears running at 5 RPM and over. 3. The level of tolerances shown for new installations, with gears running at less than 5 RPM, is calculated by adding an additional 50% to the runout allowance. 4. The acceptable tolerances should be applied to installations that have been in use for a period of time. These are unlikely to attain the original tolerances. 5. This is just a guide. Values specific for any particular gear should be obtained from the gear manufacturer. This picture shows how to measure the girth gear radial runout. This picture shows the allowable rim face runout is a function of the gear diameter. Girth gear axial runout. 1. Axial runout occurs when a gear wobbles from side to side as it rotates. Some side-to-side movement is inherent in the design of rotary equipment, however, the tolerances are small. Excessive axial runout will wear gear teeth unevenly, cause uneven pressure on the pinion, and will magnify other problems that the unit may have. 2. When correcting gear runouts, the axial runout is generally corrected first. It should always be measured using two dial indicators, 180 degree apart, usually at the horizontal center line of the gear. The stands used for the dial indicators must be rigid so as not to sway and give false readings. 3. The gear should be divided into 12 equally spaced segments, and the side rim of the gear should be cleaned in these areas. As the rotary kiln is slowly rotated, readings are taken on both indicators. The readings directly opposite each other are then mathematically averaged to find the amount of wobble in the gear. 4. The reason for using two indicators is to negate any axial float of the rotary kiln and any wobble of the thrust rollers. We follow together. Girth gear axial runout. In this picture, Recommended runout, 0.001 inch. Foot pitch diameter. From the previous show. 1. Illustrated on the chart above are typical curves, for the amount of acceptable axial runout of girth gears for rotary kilns, and similar roller-supported machines. 2. The allowable axial runout is a function of the gear diameter. For the most part, gear manufacturers and OEMs of rotary equipment recommend 0.001 inch of axial runout per foot of pitch diameter. This rule applies to new installations, and to gears running at 5 rpm and over. 3. Another level of tolerances is shown for new installations, with gears running at less than 5 rpm. This is generally a 25% additional runout allowance. 4. The acceptable tolerances should be applied to installations where the unit has been heated and expansion has taken place, or where is present. In this case, it is unlikely that original tolerances can be attained. 5. This is just a guide. Values specific to any particular gear should be obtained from the gear manufacturer. 6. Gear runout measurements are used to set the gear originally, and can be used anytime thereafter to check alignment. This picture shows how to measure the girth gear axial runout. This table shows the value of runout measurements. This table shows girth gear axial runout form. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.